Alright guys, welcome back to another segment of GGTutoring, and today we'll be focusing on the Oxymercuration-Reduction reaction mechanism that we'll need to know for the upcoming exam this week. So this reaction is fairly simple once you understand what's going on. It's pretty similar to the X2 addition with like the bromine and having the anti-addition. So you don't necessarily need to remember the reagents used bit by bit, because you'll be provided the exam reference sheet and it'll have all these different formulas, but it won't tell you what kind of reaction it is. So it's just important to recognize what we're using to be able to apply to the problems that we're doing. Okay, so this reaction is broken down into two steps. I've written in the beginning. You have the HgOAc squared 2 and then water. That's the first part, and then the second mechanism, it's just a reduction step, and you don't need to memorize this step at all because it's fairly complex and will probably be covered in later semesters. But for Chem 343 purposes, it's just important to know the products that are made and not necessarily the actual mechanism for this step. And then this mechanism follows Markovnikov regiochemistry. So with these basic principles in mind and recognizing these reagents, not necessarily memorizing them, but just be able to recognize what we're doing, it makes this reaction fairly simple. So I've drawn an example for this problem what we're going to do. So I'll start off with our first step. So electrons in the pi bond are going to come and attach. So you'll have this. And then this Hg is also going to take its lone pair and attach to make like a cyclic ring while knocking off one of its attachments. So we're going to get something that looks like this. And now you'll have some water floating around, because as we know in our first step we use the reagents and it has some water. So we're going to have water just floating around there in solution. And because Hg and OAc have attached syn to the pi bond, this can only attach anti, which is how it kind of controls regiochemistry in this reaction, where you can't have a mixture of like anti or syn, it can only be anti-addition. So this water is only going to attach, so both these carbons are partially positive in this pi bond, but this is the smaller one, while this is the bigger partial positive because it's more substituted and can distribute its charge better. So this water molecule is going to add anti to the more substituted carbon with the higher partial positive charge. So it's going to take its lone pair and attack and add here. It's going to break this bond, and then we can draw what happens. And then you're going to have more water in solution, so you're going to have to protonate as well. So again, you have these lone pairs. It's going to come and attach, take this hydrogen, and then the electrons in that bond are going to go to the oxygen to stabilize it. And you'll get something that looks like this. And now this is for the step we don't need to memorize in the reduction step. The OH is going to stay the way it is. But basically, this group that I've circled, it's just going to turn into a hydrogen, basically, with these reagents. This second step is going to make this possible, turning that to a hydrogen. You don't need to know the actual mechanism behind it. You just need to recognize that that second step is going to turn the circle group, the HgOAc, into a hydrogen. And then you're basically going to get products that are very simple and just going to look something like this. And you get a pair of enantiomers, so it'll be something like this in the dash and wedge form. And then just recognize that I haven't drawn it, but there's going to be an implicit hydrogen that has added, but you don't really need to worry about that too much because you should already know what's there. And that's basically it. So this is a very simple reaction. You just need to really recognize the reagents. It's just if you know how to already do the bromine addition, this makes this reaction much more simpler. If you don't understand this yet, I suggest you go back to our older videos and watch that, and then come to this video. I think it would help a lot. And just, yeah, guys, I think that's basically all I really need to cover about this reaction. If you have any more questions, please drop them in the comments down below, and I hope this was helpful. Thank you guys.